Okay, hi everybody. So in this video, I want to just introduce some operations that we can do with sets, namely three of them, which are the union, intersection, and difference of two sets. So if A and B are two sets, then we say the union of those two sets, and the symbol for the union is right over here, this cup-looking thing, is going to be all elements X that are either in set A or in set B. Okay, so they don't have to be in both, as it's going to be the set of all elements that are either in A or in B. And so the union, that's like our OR that we were working with before. In intersection, when we talk about the intersection of two sets, we use this upside down symbol from before. We call this like a cap. And this would be the set of all elements X that are both in set A and in set B. So this would be the intersection of two sets, or the elements that would be in both of those sets. And one thing that's important to note here is that the union of A and B, this is equal to the union of B and A. And the same goes for the intersection. So it doesn't matter what order we do these operations. As with subtraction, it does matter the order that we do a difference of two sets. So we define the difference of sets A and B in terms of A minus B as all of the elements X that are in A but not in B. Okay, so let's take a look at an example. So let's let set A be 0, 10, and 20, and set B is going to be 0, 4, 8, 12, 16, 20, and 24. And let's say we want to look at, in number one, we want to look at the union of A and B. So remember, this is going to be all elements that are either in A or in B. So basically, we just combine all of those sets together, and if an element occurs in both A and B, we only list it once, right? We don't list it two times. So these are all of the elements that either appeared in A or they appeared in B, or maybe they appeared in both of those sets. Okay, in 2, we're looking at the intersection of A and B. So this symbol means intersection of A and B. And for this one, we'd be looking for what are all of the elements that are in A as well as in B. So the 0 is in A and 0 is in B, so it is going to be in the intersection. 10 is in A, but it's not in B, so it is not in the intersection. 20 is in A, and 20 is in B, so that is in the intersection, and that's it. So all of these other values that appeared in B but didn't appear in A are not going to be in the intersection. Okay, in 3, we've got A minus B. So we're taking the difference of A and B. And so by definition, this is going to be all of the elements that are in A but not in B. So we've got 0, 10, and 20 are in A. Out of those elements, only 10 is not in B. So the difference of these two sets is just going to be the single element, the singleton 10. Since 10 is the only element in A that does not occur in B. And if we change the order of this difference, now we're going to be looking for what are all of the values that occur in B and do not occur in A. And since 0 is in A, it would be taken out of this difference. 20 is also going to be taken out of this difference. So it's going to be the set B minus 0 and minus the element 20. And that we've expressed over here with 4, 8, 12, 16, and 24. So notice the 0 and the 20 have been removed. Okay, so these examples dealt with finite sized sets, right? Set A had 3 elements and set B had a finite number of elements. On the next slide, I want to do some examples for sets that have an infinite number of elements, namely sets of numbers. Okay, so just to recall some notation and some sets of numbers that we've been referring to, the complex numbers get denoted with this cool looking C, and these would be the sets of all real and imaginary numbers, and we can write this set using set builder notation as the set of all numbers x plus iy, where x and I are any real numbers. And then, so that would be our largest set of numbers set. And then below that, we have the set of real numbers. And then below the set of real numbers, we have the set of rational numbers, which are all of the fractions. And then within the rational numbers, we have a smaller subset, and we'll talk about subsets in class, called the integers. And then inside of the integers, a subset of those numbers would be the natural numbers. So all of these sets have infinite numbers of things. So let's think about how we could express the union, intersections, and differences of these sets. So in number one, we are asked to calculate the union of the real numbers and the natural numbers. So this would be saying, what are all numbers that are either real or natural numbers? And since all of the natural numbers are themselves real, when I look at this union, I'm just going to get back all of the real numbers. In two, we change the operation from a union to an intersection. So now we're not saying what are all of the values that are in either one of these, but we're saying where is the overlap between these two sets? What numbers are in both the real numbers and in the natural numbers? And since the natural numbers sit perfectly inside of the real numbers, every single one of these natural numbers is also a real number. So the intersection of these two sets would just give us the natural numbers. In three, we're now looking at the difference of natural numbers and the real numbers. So this would tell me what are all of the numbers that are in the natural numbers but are not in the real numbers. And here, since every single natural number sits inside is a real number, that would mean that this difference contains no values. There are no natural numbers that are not also real. So this is empty. So we could denote that with the empty set. This means there are no such values in that difference. If we take a look at the difference of the integers, so in 4, we're going to take a look at the integers minus the natural numbers. So that's going to be what are all of the numbers that are in the integers but not in the natural numbers. So that would be basically all of the integers less than or equal to 0. So that we could write ... minus 4, minus 3, minus 2, minus 1, and we stop at 0. So these would be all of the non-positive integers. Okay, so there are some practice problems for you to work on the quiz, and we'll work with some proofs using set theory in class on Monday. Take care.